So today we'll continue with the applications of factoring. Last time we learned how to solve equations using factoring. Today we're going to see another topic when we use factoring, and it's about rational expressions. So we'll see how to basically apply factoring to simplify, multiply, and also divide what we call rational expressions. Okay, so before we get into that, let's first define rational expressions, see what they are before we learn how to multiply them and divide them. So the short definition is rational expressions are basically fractions. That's what they are. They are basically fractions. Maybe a different type of fractions, but they're just fractions. All the rules on the properties of fractions apply to them. So everybody should know their fractions very well, the addition, multiplication, and all that stuff, because we apply the same thing to rational expressions. So review your fractions if you have issues with them, all the operations, like I said. I'm going to be doing some examples of that, but the more you know fractions, the easier this will be. So rational expressions are, like I said, fractions. Fractions in this form, not just numbers, not just with numbers, but also with variables. With variables, or basically polynomials. So it's a fraction made with polynomials. Two of them, monomials, binomials, trinomials, all sorts of polynomials that we saw. And of course, the denominator can't be 0, because as you know, we can't divide by 0, it's undefined. So that's what a rational expression is, two polynomials. Example, 2x minus 4, and let's say maybe x, or just 2x, for example, 2x plus 3. So that's a rational expression. As you can see, we have a binomial here and another binomial. Could be also a trinomial. Well, for example, something like this. Okay, a binomial over a trinomial. Could even be something like we've seen before. We've seen expressions like these before. When we talked about the exponents and the power and the rules of the powers and exponents. So that's basically what rational expressions are. They are basically fractions. The only difference is they're not just made with numbers, for example, 2 over 3, but they're made with some polynomials, some variables. The variables are themselves are numbers that we don't know or may change in value. So they're still just fractions at the end of the day. So when we have expressions like these, just like we do with the regular fractions, we can add 2 of them. We can, for example, multiply 2 of them, divide, do all sorts of operations. We can also simplify them, same way we simplify regular fractions. So let's see how to simplify. Let's see how to simplify rational expressions. So for example, if you take a regular fraction, 15 over 10, that's just a regular fraction, we can reduce it, or we can simplify it to lowest, or to lower numbers, to smaller numbers. So how can we reduce or simplify, for example, 15 over 10? What can we reduce it by? Everybody, we want to reduce this fraction 15 over 10. How do we do that?
Divide by 5.
That's right. We can reduce it by 5 because they both have 5 in common. We can write 15 as 5 times 3, 10 as 5 times 2. Basically, we kind of factored it here. We turned it into a product of two factors, 5 and 3, 5 and 2. And you see that 5 is a common factor that can be canceled out, that can be reduced. We can cancel out 5 and 5. We end up with 3 over 2. So we reduce this into a smaller fraction. Still the same fraction, still the same quantity, but this one is simplified. We apply the same thing. We can apply the same thing to fractions or to rational expressions like these. For example, we have 5, and you have x plus 1 over, let's say 3, and x plus 1. Same thing applies. So we have 5 times this, 3 times this. It's the same factor here. We can cancel it out. And this turns into 5 over 3. So we'll reduce or we'll simplify expressions the same way we do with fractions. So everything, again, everything that applies to regular fractions applies to rational expressions, including simplifying. We can also simplify this, for example, x to the second minus 4 over x to the second plus of x plus 6. The only thing is we can't just cancel x2 and x2 right away. We can just cancel them. We need to first have this in the form of a multiplication like this. Have to be multiplications only between the numbers or terms, not subtractions or additions. So before we can't just cancel x2 and x2, we can't just reduce 4 and 6. We'll have to turn it into some product, some multiplication. So what do we do to turn each one of these polynomials into a product of terms or factors? What is that process again called?
Difference of square.
Difference of the square. So we need to factor first. So before we can cancel things out, we need to factor. So we basically factor everything you can. So factor all the, whatever you have to factor. And basically, as you can see, we have two polynomials here, binomial, trinomial. You can use the difference of 2 squared here, so x minus 2. X plus 2, plus 2. How do you factor the other one, the bottom?
3x plus 3, x plus 2.
X plus 2, x plus 3. That's right. So as you can see, now we can cancel, okay? Do not cancel here because we have additions and subtractions between the terms. It will have to be turned into a multiplication using factoring. Now that we have factors of terms, basically like having this times this and this times this, we cancel the 5s here. We have a multiplication here, also multiplication here. So we can cancel the common ones, x plus 2, x plus 2, they're common. We're left with x minus 2 over x plus 3. So that's basically how you simplify rational expressions. It involves factoring. So everything again comes down to factoring before either simplifying, before multiplying or dividing, as we're going to see. We can basically simplify any rational expression if it's possible. Not every fraction, not every rational expression can be simplified. So we factor first and see if we can simplify it. We've seen how to simplify this. We've seen this before when we talked about the roots of exponents. So 15 or 15 over 35. So what do we do here to simplify this expression?
We can find GCF.
GCF, we don't need to factor this. It's already factored basically. As you can see, it's monomial over monomial. So we just need to reduce it.
The common
common number, or when I reduce this, right? The common, just like here.
5.
That's right. So we can reduce this by 5. So you can
3,
see.
3.
you skip y on the bottom. 5.
Okay.
Y 5.
That's right. The y, there's a y there. Yeah.
Yeah. So it's 5x y power 2.
That's right. So we're going to reduce this by 5, and we have what, x3 over x1. What do we do with the powers again?
X, y, 2.
So we need to reduce, we need to
No, we
subtract.
Yeah.
So we subtract the powers when you have fractions, so 3 minus 2.
3 minus 2, yeah.
That's
3
right. And then we
minus
have,
1, no?
that's right. Then we have y2 over y5, also subtract the powers. Now we're going to simplify a little more, cancel the 5s.
What's that? 3 minus 1.
3 minus, yeah, that's right. It would be 2. 3 minus 1, which will be eventually 2. So 3 minus 1. And the y to the power -3, which will move down, becomes power 3. So instead of putting y to the -3 here, we move it down to make it positive. So that's also simplifying rational expressions. This is a monomial over a monomial, one term over one term. And we didn't have to factor these. And if you have binomials, trinomials, and more, we can always factor when possible before simplifying. So, so factor first. So to simplify, basically, factor first. And cancel common factors. Okay, so that's pretty much how easy it is to simplify rational expressions, and everything we learned about factoring applies. So again, always try to find the GCF. So most of this again is factoring. The rest is simple. So GCF, after GCF, you may try grouping or trinomial factoring, or maybe binomial. So all the methods of factoring that we learned apply here too. Okay, so that's simplifying rational expressions. So factor first before canceling out. Again, don't cancel right away. If you have additions or subtractions between the terms, you can't cancel until you make it into multiplications. It has to be all multiplications between the factors before you cancel the common factors. Okay, any questions about this so far, everybody, before we go to multiplication and division? Everyone, any questions? Okay, there are no questions. Let's look at multiplying. So we can actually multiply two of these, this and this, same way we multiply two regular fractions. So before multiplying fractions or rational expressions, let's do some examples with maybe some regular fractions, see how to multiply them. Let's say you want to multiply 15 over 8 by maybe 35 and possibly 16. So let's first review how to multiply regular fractions, because the same thing applies to rational expressions. How do we multiply fractions in general? Everybody, how do we multiply fractions? Which way, or what do we do to multiply them?
Cross multiply.
Not cross multiply. I don't know why everybody always says cross multiply when we multiply fractions. We do not cross multiply. Everybody else, how do we actually multiply fractions? Which way? Or
Is it find the same denominator first or whatever?
15 multiply 16, 8 multiply 35.
That's right. So we multiply straight across. We just multiply these together and these together. And the LCD, or the common denominator, we need it for addition and subtraction, not for multiplication and division. So the way we multiply fraction is straight across like this, not cross multiply. And but before multiplying, we try to simplify them first. Always try to simplify the fraction itself, like we did here. Try to simplify each fraction if possible. If you can't simplify the fraction itself, try to simplify like this, diagonally. Try maybe to reduce this way, or maybe that way. It makes it easier to multiply, especially if you have large numbers. Try to turn them into smaller numbers, like these, before you multiply them. So, can't reduce this way or that way. We can reduce this by this way by
factoring, like find a common, yeah, factoring it.
So 5 is common. And here, what is the highest common number?
Like 4 and 2 and 7 and 5.
Even higher here. So here, 5 is good. But for this one, what is the highest number?
8.
We can 8. So we can factor this way by 8, this way by 35. So again, don't multiply right away, even though you can, but it's going to be a little more complex with big numbers. So reduce first, always reduce first. So these having 5 in common, so 5 and 3, 5 and 7, and the highest number here is 8. So basically 8 times 1. This is 8 times 2, 16. Now we're going to cancel all the common factors, as long as it's 1 from the top against 1 from the bottom. They can't be on the same side. It has to be 1 from here, anywhere here against 1 from here. So the 5s cancel out, 8s cancel out. We have 3 over 2 over 1 times 7. That's what's left to multiply. So instead of multiplying these big numbers, as you can see, now we only have to multiply this, which is easier. You can do it without a calculator, without doing the math on the side. And that's the product of the two. Okay, easy. No, again, no calculation needed, no calculator. So the same idea applies to rational expressions. So when you multiply two rational expressions, you can apply the same thing. So let's say, for example,
Professor, is simplifying always the cross way?
Simplify within each fraction if possible. If not, simplify, cross simplify, yes. Not
Okay.
simplify this way, has to be
Both
cross
ways
simplify.
correct. So both ways correct.
Yeah, both ways this way. So 1 from here against 1 from the bottom. So same when you have rational expressions, we can do that. For example, if you have x plus 2 and maybe 5 over 3, x plus 1, actually x plus 2 over x plus 1. So we want to multiply these two rational expressions, but again, don't start to distribute and then multiply all this by all of this and this by all this. It's going to be a lot of work. So what do we do instead before multiplying?
We can simplify all parentheses.
That's right. So we can simplify all the common factors. So
Yeah.
simplify this way if possible. Nothing is common here. Nothing is common here, but diagonally, we can see that we can cancel that one out. We can also cancel. That's right. X plus 2 and x plus 2 cancel out. What's left to multiply now?
7 and 5 and 2 and 3.
That's right. 7 and 5, 2 times 3.
35 over 6.
That's right. 35 over 6. And that's much easier. We didn't even have to deal with the x's and distributing and multiply this by this. So we do not want multiply right away. So we do not want to multiply right away. If you do that right away, you're going to have to do a lot of multiplication, a lot of multiplying, a lot of adding terms and factoring, but it's much better to simplify first. Always simplify first. Or before simplifying, you may have to factor. Factor and simplify first. That's very important. So we get a factor and simplify. Let's see another problem. So let's say you have 3x plus or minus 6. We want to multiply this by maybe let's do second minus x minus 6. and some other polynomial. Maybe x to the second minus 4, and maybe another trinomial here, or just a couple of terms. 2x plus 4, for example, here. So again, we'll have to, so we have a multiplication of two fractions. Basically, they're fractions. We know that we can just multiply them straight across, but we don't want to do that. So again, we'll do like this. We're going to simplify factor first, turn them into a multiplication of factors like this, then simplify or cancel all the common factors. So before multiplying again, factor all these polynomials, binomials and trinomials. So the first one, what do we get if you factor the first one?
3x minus 2.
So that's right, it will be 3x minus 2. Let me just change, let me actually make this one a plus. Make this one a plus, it'll be 3x. Actually, not a plus, I want to make it a 9 instead. This would be 3x minus 3, and factor the binomial, difference of two squares, what we get from that. This will be
X minus 2, x plus 2.
that's right, and also here, so 2 is a common factor, we 2, x plus 2. Finally, the trinomial. How do we factor this trinomial? This one here. Trinomial factoring. Two numbers that multiply to -6 and add up to -1 are. Everybody?
-3, +2.
Minus 3 and x plus 2.
That's right, x plus 2. Okay, so we factored everything. What do we do next? Before multiplying.
Cancel.
Okay, that's right, cancel. Common factors, all of them, before multiplying. So it will make things a lot easier. So this turns into, or what do we cancel? Any common factors, one from here.
X
+2 from the top and the bottom.
x plus 2.
+2.
Okay, so it looks like first we can cancel within each fraction if possible. Nothing cancels here, but here we can cancel this with this. And we can also cancel this way. We have x minus 3, and that's it. That's all we can cancel. The x plus 2 is already gone against this one, so we can't cancel it against this one also. It can only be done one way, either this and this, or this and this. So cancel as much as you can. Now what's left is 3 multiply 2 over.
X
We
minus
have,
2 and x plus
that's right, x minus 2, x plus 2. Which is basically, this is 6. So that's pretty much the product of these two. And you don't actually even have to multiply, just leave everything factored like this. No need to actually distribute and combine like terms. We prefer expressions to be here like this in factored form, just in case you want to use them for something else, for another multiplication or another division, or maybe another addition. So that's basically the answer. So just cancel as much as you can by factoring first. And so all this now basically turns into something a lot simpler, just this. Sometimes maybe everything will cancel out like this. Maybe all x's will cancel out and end up with just a regular fraction with numbers. If not, you may have some factors left here, but that's fine. Again, no need to distribute. Just leave that alone. So we multiply 3 and 2, that's good. But x minus 2, x plus 2, that's fine. You can leave it like that. Or if you have another term from here, for example, x minus 2, and you have something left here, for example, this x plus 2, you don't have to distribute that, just leave it like that. So that's how the multiplication of trinomials works. Just basically by canceling, you avoid a lot of multiplying, a lot of adding and subtracting. So that's why it's very important to factor and simplify first. I'll give you another example, this time with maybe just monomials. Any questions, everybody, so far about multiplying before we go to another example? Everybody? So let's see another problem, maybe a little different. So let's see how to multiply something like this. We've seen these before. Let's see how to multiply basically x and y, maybe some y here. And it could be of numbers, for example, 15 and 10, and maybe 4 and maybe 4 here. So make this one a 5. Okay, so same thing here, we're multiplying two rational expressions. Only difference here is these are all monomials, so no need to factor the variables of the expression. So technically already factored. Unlike here, we had additions and subtractions, we had to factor first. It's already factored here, we just need to simplify. Before multiplying it right away, it's probably a good idea to reduce first. So especially the numbers, you have 15, 8, 4, 5. So before multiplying those, let's reduce them. Try to reduce within each fraction, possible. If not, we're going to again cross simplify. We have 5 and 15. We can simplify those by 5. For example, 5 goes into 15, 3, 5 into 5,
1.
Once. And this way, you have 4 and 8. What's the highest number we can reduce by?
1 and
By 4. That's right. 4 into 4 once, 4 into 8 twice. So let's first multiply those numbers and see what to do with the variables. So we have 3 times 2, that's 6. 1 times 1, of course, that's 1. Now, what we can do is we can simplify within each fraction first before actually multiplying straight across. So within this one here, what can we simplify within the same fraction?
X.
We can reduce the x. We have x3 over x5.
It will be negative x, so we can move it to the.
That's
bottom.
right. So 3 minus 5 will be minus 2. If we move it down, it will be x2 to the bottom. So that's reduced. Then we're going to multiply it by this also. We need to reduce it. We have one here over the y. So it'll be x4, right? And y7 over y1 is y6. Now let's see if we can multiply anything. So first, we can let's see, we can multiply these two together. Y2, y2, y6, that's right, is y8. And we can also reduce the x's. It would be
X2.
That would be x2, so x4 over x2. So if we have a fraction, it's something over something, we subtract the powers. 4 minus 2 is 2. But if you multiply them, they're on the same side. X2 times y6 is y8. Again, these are the rules of exponents we saw before. So we did these together, and these two together. And over 1, which is irrelevant, the 1, we can just say 6 y8 x2. This is one way to do it. There might be a slightly different way to do it. That's fine. But again, try to reduce first. Don't try to multiply everything at once and then simplify. It's better to simplify first so you don't run into large numbers or complex expressions. You may again do it in slightly different steps. That's okay. As long as you get the same answer, it's not a problem. So that's basically how the multiplication of rational expression works. It's pretty simple, as you can see. Again, it's all made easy thanks to factoring. So that's why, again, I mentioned before that factoring is very important. So make sure you know your factoring very well, because knowing factoring can make this a lot easier. You saw last time how we solved equations easily, quadratic and third degree equations easily using factoring. And today you see that we can make these rational expressions pretty simple by factoring and simplifying them. Okay, so now that's the multiplication. The division is almost like this. The division is almost exactly like that, except we need to do one step first, one extra step in the beginning. So division of rational expressions. So again, before dividing some rational expressions, let's just review the division of fractions with some regular fractions. So you have 5 over 4, divide maybe 8 over 15. So how do we divide fractions again in general? What do we do first when we divide fractions, everyone?
Simplify.
Simplify is part of it, but before simplifying, what can we do here? There's a division, so, or in general, which way we divide fractions?
We flip the
Sorry, say it again.
we flip the divide part. I don't know.
To the
Okay.
end.
Okay. So for multiplication, we multiply this way. For division, you may multiply this way. You could cross multiply. So for multiplication, we will multiply this way, but for division, we may cross multiply. But instead of doing that, we can actually turn this into a multiplication. So you don't want to multiply right away again. You could if you want to multiply this way, but you don't get a chance to simplify. So try to simplify first. And to simplify, all you have to do is make this into a multiplication, turn the division into a multiplication, 5 over 4.
Yes, we're by 5 and 4, yeah.
That's right, multiply, so the
That's
division
like
turns
1
into a
over
multiplication.
2. We won.
Okay. And we flip
15 and 8.
the second one. Okay, so we basically turn the multiplication into, or the division into a multiplication, and we flip the second one. Only the second one flips, not the first one. That's one way to do it instead of cross multiplying. So I don't suggest you cross multiply. Turn it into a multiplication first, and then repeat all of this again. So
Well, first, can you simplify before you you put you do it as a multiplication?
If you simplify,
Mm-hmm.
you could, yes, you could simplify first, but it's better to turn it into a multiplication. Let me change the numbers a little bit. Let me flip this one, 15 over 8. You could, but we prefer to do it afterwards. So turn it into a multiplication first. So this turns into a multiplication, flip the second one, 8 over 15. Now you can reduce. That's why I suggest that you flip it first before cross multiplying. Flip it first to turn it into a multiplication, and again, all this applies. So forget about the division now, it's a multiplication, so we're gonna do whatever we've done here. So before multiplying again, before multiplying straight across, we will reduce. We'll reduce this, so this way we're gonna reduce by 5. So 5 into 5 once, 5 into 15 3 times. This way, what is the highest number? Goes into 4 and 8. we reduce this by 4. So 4 into 4 once, 4 into 8 twice.
2.
That's right. Now we're going to multiply these two. So 1 times 2. 1 times 3. That's 2 over 3. Okay, so change the division into a multiplication and reduce. So turn or change the division to multiplication and reduce or repeat whatever we've done. Repeat all of this, basically the previous things. So division is almost multiplication. So one step here, and we repeat the whole thing all over again. If you want to reduce it, you have to reduce this way, not this way. If it's a division, you may have to reduce this way. Or after you multiply, or you turn the division into multiplication, you cross simplify. But again, you can stick to one method, just turn the division into multiplication and repeat the same thing. So you don't get confused whether to multiply, cross multiply, that can be confusing. So there's no cross multiplying, it's all straight across. Straight across, you have a multiplication. If you have a division, turn it into a multiplication and again, multiply straight across. So let me give you a few examples here. Let's say you have 5x minus 10, and let's say I want to divide this by maybe x to the second minus 4, and maybe a couple of polynomials here. Start with this one here, x to the second, maybe plus 5x plus 6. And something else, x to the 3x plus 9, for example. Okay, so again, this doesn't have to look complex. It's actually not that difficult, as you will see. So remember what to do. So it looks like a division of two fractions. That's how you should look at it, division of two fractions. So remember the first thing to do. So what is the first thing to do again when you divide fractions? Just like the previous example, what do we do first, everybody, when we have a division of fractions?
Change it to multiplication.
Reciprocate one.
That's right. Change the multiplication or the division to multiplication. So we can apply all this again, the same thing. So first one, so before you simplify, before you factor, before you do anything, just change the multiplication into a division. And we'll see what to do afterwards. All right, so again, once you have a multiplication, you're back to this. So everything we've done here still applies. So what happens next?
Simplify.
That's right. And factor first. So factor everything as much as possible. So if you factor here, so the first one, that would be common factor is 5. So
5x minus 2,
okay, over
3x plus 3.
okay, multiply. We're going to factor the other two. We have a trinomial.
Yeah, x plus 2, x plus 3,
Okay,
x minus
over
2 plus 2.
that's right. X minus 2x plus 2 binomial factor. Okay, so factor everything, and then once we factor all, what happens next? What do we do now after factoring everything, everybody?
So comment.
Canceling.
Cancel or simplify all the common ones. Again, it has to be one from the top against one from bottom, from anywhere. As long as, or start simplifying within each fraction first. Can't cancel anything here. Can we cancel anything within this fraction, the second one? Can we reduce anything?
X minus 2 from the top and the bottom.
Okay, or within the same fraction here, can we reduce or cancel anything?
X plus 2.
That's right. So always try to reduce within each fraction first by itself. So that's gone. Now we can see cross simplify. So we have x plus 2 and x minus 2, x minus 2. Anything else cancels out?
Y plus 3.
X plus 2.
That's right. X plus 2, x plus 2 also cancels out. So we don't have much left. What's left now? From the top here, only the 5 is left. That's right. From the bottom, only 5 is left. 3. So that's it. That is the product, or that's the quotient, the division of the two. That's the quotient of these two. It's basically just this. We didn't actually have to imagine if you multiply this by this, you will distribute all of this over this, distribute all of this over this, combine like terms and everything, just to get to this point. You're still gonna get here, but it's gonna waste a lot of time, and you may get some sign wrong or something, and you can get the answer wrong. But with, as you can see with factoring, we have a lot of common factors, they all canceled out. And that's all we have left. So that's basically how you divide. Just turn it into a multiplication. And the rest is simple and the same as we've seen here. But again, you should know your fractions, the basic fractions like this, you should know this. I know we reviewed them, but again, if you know them well, the concept is the same here. It's still the same concept, as you can see. We flip it, we cancel, and then we have something small to multiply. Instead of multiplying large numbers, we have only had to multiply smaller numbers like these. The answer is simple. You only have to simplify it and so on. Any questions, everybody? Let me know before we do another one. Okay, so let me give you another one. Say x over y. Let's make some fractions now. Divide this by some other fraction. 17 x over maybe 16 here, and y to the second. Okay, so this one should be even easier. No factoring is needed here. These are just monomials with one variable. So again, first thing, I need to flip this, make it into a multiplication. So 3x. Before simplifying, before doing anything, make your division into a fraction, into a multiplication. So the division turns into a multiplication. Flip the second one. Only the second one flips. And the rest is basically simplifying. So turns into something like this. So multiplication of two expressions. So what needs to be, what do we simplify here first? Everybody, what do we simplify before multiplying? Can simplify the numbers themselves, the numbers within each fraction. Okay, so which way do we reduce or simplify this again?
We can simplify in the first one, but in the second one by 3, no?
Okay, so we try to simplify within each fraction if possible. Nothing cancels here or here, same thing here. Now we're going to try to cross simplify. So this way we can reduce by
3 by 3.
by 3. So 3 into 3
We
once.
cancel 3, and we get 5
That's right. 3 into 15, 5. And then this way,
by 8,
by 8. So we have 8 into 8 once, 8 into 16,
2.
be twice. Okay, so let's multiply those first, then see what to do with the variables. So we have 1 times 2, which is 2. 1 times 5 is 5. So again, that's easier than multiplying 3 and 16, 8 and 15. So now that's done, it's simplified already, so no need to do anything else. You may also, the x's here, you can reduce the x's this way. Or let's just multiply first and then reduce. You can reduce this way, x2 and x5, but if it's too much, you can just say x2 times y2. Okay, so we multiply straight across, y4 times x5. And by multiplying them, we mean just write them next to each other because we can't do anything with those two because the bases are different. Same thing here. But if we can't multiply, we can definitely simplify this way. So the x's, we have x2 over x5, which is would be x minus 3 here. If we move it down, it becomes x positive 3. Same thing with the y's. So basically we're doing these two together, and also these two together. So the x's here and y2 over y4 is y negative
2.
That's right, y negative 2, which will move down. Instead of writing here with a negative, we write it down here with positive. Okay, it was here initially, it was like this, but we moved it down and it turns positive. And that's it, that's pretty much it. There's nothing else we can do. This fraction, as you can see, is simplified. There's nothing to simplify. We can't do anything else with these two. They have different bases, and we're pretty much done dividing these two rational expressions with these two fractions. So the rules of exponents, they still apply. And in addition to factoring, these are the key things here. The whole class is based on these. So rules of exponents, factoring, and also the rules of fractions. So those three are basically the main things in this class. So fractions, and of course, not to mention the signs. So if you don't know the signs, this can be very difficult without knowing the signs. So these are the 4 skills basically needed in this class. If you know those very well, the rest is just, it will be repetitive. It will seem very easy, very simple, as you can see here. So review all this again, and you shouldn't have any problems with this class. Okay, any questions, everybody, about the division here or anything else we talked about? Everybody, please let me know. That's pretty much it for the division and the multiplication and simplifying rational expressions. The addition and subtraction is a little different. We'll do that in the next class. As you know, when you add and subtract fractions, we need a common denominator. So next time I'm going to see how to find a common denominator for things like this. Now you can find a common denominator for like 4 and 8 and so on, but we will see how to add 2 of these instead of dividing with the addition. We're going to learn how to make the denominators the same, because if they're not the same, we can't add or subtract. So that's another interesting one. And again, factoring will make it very easy. Factoring will make it very easy to make these look the same or to make the common denominator. So we'll talk about that next class. So again, please let me know if you have any questions. If not, I'll give you a few problems to do by yourself. So first, again, simplify some rational expressions. So let's see, 21, 14, x. Okay, so to simplify this again, this is something we have seen a while ago with the exponents. Also, let's say another easy one here, just so we can understand what we're doing. So that, and possibly so x to the second plus x minus x, x second minus 9. So simplify that. And also some multiplication. Multiply, divide the following. Let's see. So okay, so in x and x, we have a trinomial here. Maybe another trinomial over here. Let's say x to the second plus 5x plus 6. Okay, so multiply all that. And maybe a division. So let's say 14x y divide this by another one. Let's say 5 21 over 35. Just the third y. Something like this. Okay, so most of these are pretty simple, but again, they're not that complex. Think about factoring again, and also think about the basics of fractions. The same concepts of basic fractions apply to rational expressions. Okay, so that's your practice. So work on it. Give you a few minutes. Okay, simplify here and multiply and divide. That sums up pretty much everything we've done today. Okay, so give you about 10 to 12 minutes. You may take a short break if you wish before doing the practice. And I'll see you again in a few minutes when we go over this together. Okay, so this is your practice.
Professor, 7x plus 12 with multiply.
Yeah, 7x plus 12.
Okay.
Mhm. Everyone, let's go over these problems. Did you get here with the first one? Everyone, did you get here?
3y power 6.
3 y to the 6, okay. What else?
And 2x.
2 y, no, x on mine, on
2x to the
only x.
x, 2x, that's right. So subtract the powers, reduce this by 7. This one, of course, simple. What is that equal to, everybody? Everyone, what is that equal to?
7
Mm.
divided
Right.
4.
Cancel both x minus 2 because
That's
of
right.
4, yeah.
Let's cancel these, and we have 7 and 4 left. What do we do first here?
Factor.
Factors, so x minus 3, x plus 3 over, what do we factor this trinomial?
Minus 2 plus 3.
Okay, x plus 6 minus 2, and then what cancels?
Then cancel. X
Okay.
minus 3,
Plus
x
3.
minus 1.
That's right, we cancel these two, so x minus 3 over x minus 2. That's the final answer. Now we have a multiplication of two rational expressions. What is the first thing we do again?
Factoring.
Right, so we're going to factor everything as much as possible. This would be 6x minus 2. And this trinomial would be
Plus 3 plus 4.
that's right. Trinomial, and then another trinomial. It's x plus 2, x plus 3. And finally, a binomial, x minus 2.
Minus 2, I should multiply x plus 2.
That's right. So now we're going to cancel all the common ones. So what cancels?
X minus 2 with x minus 2.
Okay, those two cancel out. And
X plus 3 with x plus 3. And x plus 2 with x plus 2.
right, and also this x plus 2 against this x plus 2. So what's left is
6 over x plus 4.
right, only 6 left at the top and over. So this is x plus 4, only thing left. And that's it. So that's the product. Again, we didn't have to even to multiply because we simplified. It's not nothing much left to multiply, but these two. Last one here, we have a division of two rational expressions. What is the first thing you do again when you have division? Everybody?
Flip the second term. Multiply by flipping the second term.
Change
Right.
division to multiplication.
That's right. So first one stays the same. Turn the division into a multiplication and flip the second one. So 35xy, the fifth over 21x to the third. Now it's a multiplication, so again, reduce as much as possible first before we multiply. So what do we reduce first?
Simplifying.
Simplify, okay. What exactly do we simplify first?
14 divided 3. No,
That's right.
no, sorry. Yes, 14. So
So we try to simplify each
results
fraction.
14 divided 3.
Okay, so we can reduce these two by 7. So 7 into 14 twice, 7 into 21 3 times.
Yeah.
Also this way, we can reduce by
5.
5. 5 into 5 once, 5 into 35, 7 times. So let's multiply those numbers. First, so we have 2. 2 times 7 would be 14. And 1 times 3 is 3. So we're done with the numbers. Now we'll do the fractions. So we can reduce this first before multiplying it. We can reduce it. So we have the y's here, we can reduce them. So x4, y7 over y2 will be y5.
5.
That's right. And we're going to times that by this, but again, reduce it also if possible. What do we reduce here?
X2 on the bottom.
That's right. So we have x1 here. If we subtract them, we get x negative 2 at the top. We move it down, will be x2. And the y5 stays here. This y5 stays the same. We can keep simplifying. So we have 14 over 3. We have x4 over x2 now. We can reduce those. So x4 over x2 is x2. Then we have y5 times y5, which is
Y2. Y10.
y10. Right? We add the powers. So these two together, the powers add up. These are in a fraction, x4 over x2. We subtract the powers, we get 2. And that's pretty much it. This is the final answer here. Nothing else we need to do. And that's pretty much how you multiply, simplify, and divide your rational expressions. We'll see the addition and subtraction in the next class. And again, it involves factoring extensively. So factoring is very useful. Okay, everybody, any questions about any of this? About this practice, everyone? Just let me know before we take the attendance.